Welcome to everyone. I am Brinda, BC Physics second year in Dr. Umayama College for Women. Today chapter for Analog Digital Communication Systems. Going for topic IC741 op-amp and pin diagram. IC741 op-amp in the pin diagram. The pin diagram of the IC741 op-amp is shown below. It consists of the 8 pin where each pin having some functionality which is discussed in the following. Pin configuration. Pin 1 is the outset null. Pin 2 inverting input terminal. Pin 3 is a non-inverting input terminal. Pin 4 is negative voltage supply VCC. Pin 5 is outset null. Pin 6 is the output voltage. Pin 7 is positive voltage supply V plus VCC. Pin 8 has no connection. Specifications of IC741 op-amp. The specification of IC741 op-amp is input offset voltage and current input bias current, differentiated input resistance, input capacitance, offset voltage adjustment range, current voltage range, CMRR, common mode rejection radio, SVRR, supply voltage rejection radio. Consumptions of power, transmitter response and leave rate SR. And then characteristic of IC741 op-amp. The input impedance is more than 100 kilo ohms. Output is low less than 100 kilo ohms. The frequency range amplifier signal is from 0 Hz to 1 meter Hz. Low offset voltage and current. Voltage gain is about 2 lakhs. Thank you all. Thank you for watching. Have a nice day. Welcome to everyone. I am Brinda, BC Physics second year in Dr. Umayama College for Women. Today chapter for Analog Digital Communication Electronics. Going for topic Square wave generators. Square wave generator. The square wave generator is defined as a oscillator that gives the output without any input. Without any input in the sense we should give input within 0 seconds. That means it must be a impulse input. The generator is used in digital signal processing and electronics applications. The square wave generator is also known as a stable multivibrator or free running, and the frequency of the square wave generator is independent of the output voltage. The basic current diagram and working of the square wave generator are explained below. Square wave generator using an op-amp. A square wave generator using a operational amplifier is also called as a stable multivibrator. When the operational amplifier is forced to operate in the saturation region, it generates square wave. The output of the op-amp swings between the positive and negative saturation and produces the square waves. That why the op-amp circuit here is also called as free running multivibrator. Waveform and frequency ranges. With the resistor value between 100 to 1K and capacitor value of between 1 to 1000 f. This is would give a frequency range of between 1 Hz to 1 MHz. High frequency produce the square wave generator distortions. Standard TTL logic gates do not work too well as square wave generators due to their average input and output characteristic and distortions of the output waveform and low value of feedback resistor required. This is result in a large value capacitor for low frequency operation. The acceleration may not accelerate if the free value of the feedback capacitor is too small. A stable multivibrator is can be made using better CMOS like technologies that operate from a minimum to maximum apply such the symmetry inverter. Thank you all. Thank you for watching. Have a nice day.
Good morning to all. Today topic is monostable operation. Triple five timer connect for monostable operation. The steady by state FF holds transfer Q1 on this champing. The external timing capacitor C to ground. The output remains at ground potential, example low, as the trigger passing through VCC by 3. The FF is set Q equal to 0. This make the transfer Q1 off and short circuit crossing the timing capacitor C is released. As Q is low, output goes high equal to VCC. The timing cycle now behind. Since C is unchampioned, voltage across it rise. External potential thought or toward VCC with a time constant RC. After a time period T calculator later, the capacitor voltage is just greater than 3 by 2 VCC and the upper comparator reset the FF at is R equal to 1, S equal to 0. This make Q equal to 1, transfer Q1 goes on, discharge the capacitor C to ground potential. The output turns to steady by state or ground potential. The voltage across the capacitor is given by Vc equal to VCC 1 minus e power minus t by RC at t equal to t. Vc equal to 2 by 3 VCC. Therefore, 2 by 3 VCC equal to VCC into R1 1 minus E minus T by RC. T equal to RC in 1 by 3 or T equal to 1.1 or C seconds. This is basically a monostable vibrator with a modulating input signal applied at pin 5 by the application of continue trigger at a 2 pin, a series of output pulse or addend. The due modulating signal applied at pin 5 gets up on the already exceed voltage 2 by 3 VCC at the inverting input terminals of UC. This is change the signal and the output waveform or noticed output waveform plus VCC.
Hi everyone, today we are going to study about amplitude modulation in analog and digital communication electronics. First of all, we know about what is amplitude modulation. It means the process of amplitude of carrier signal changes with respect to message signal. Modulating signal is called low frequency signal. The general expression of AM signal is given by S into T equal to AC into 1 plus Ka M into T. Here AC is amplitude of carrier and MC is message signal. Ka is amplitude sensitivity of modulator. FC is carrier signal. Then we used the special equation here, that is envelope equal to AC into 1 plus Km into T. Next we discuss about what is modulation index. The definition is measure of how much a modulating signal modulates the carrier signal, is also known as depth of modulation. It is denoted as mu. It is nothing but K equal to Ka max into M into T. Then we move for what is single tone sinusoidal modulating signal. Here M into T is single tone. The single tone is the signal that have a single wave, and sinusoidal means it have a sine waves or cos waves. Modulating index is also defined as amplitude of message signal to the amplitude of carrier signal for single tone. This was written as a equation MA equal to AM divided by AC. The simple way of amplitude modulation is message signal plus carrier signal equal to modulated signal. Both message signal and carrier signal have sine waves. Both are collage with each other is called modulated signal. Thank you for watching.
Welcome to everyone. I am Brinda, BC Physics second year in Dr. Umarama College for Women. Today chapter for analog and digital communication of electronics. Going to topic for black diagram of digital communication system. The basic black diagram of a digital communication system. In the figure, the different function element are represented by the blacks shown in this figure. The essential component of a digital communication system. First one, input source. Second one, input transformer. Third one, formatter. Fourth one, source encoder. Fifth one, channel encoder. Sixth, base band producer. Base band modulator. Seventh one, channel. Eighth one, band pass demodulator. Ninth one, channel decoder. 10th one, source decoder. 11th one, deformator. 12th one, output transporter. 13th one, output signal. Input source. The input source or the source information are generally analog in nature, for example voice signal and video signal. These signals are non-electrical quantities and hence cannot be processed directly in a digital communication system. The input transfer. Transfer is a device which connects one form of energy into another form. since the information from the input source or non-electrical quantity. The input transfer convert this non-electrical quantity into electrical quantity. Formatter. Formatter is used to convert an analog signal into a digital signal. So the receiver signal from the transformer is converted into digital signal by using the formatter. However, if the source signal is already in a digital form such as a computer, then we will not need a formatter in such cases. Source encoders. Source encoder is used to compress the data into minimum number of bits. This help in effective illustration of the bandwidth. It removes the redundant bits or unnecessary excess bits, that is zeros from the input data. Channel encoders. During the transmission of the signal due to the noise in the channel, the signal may get altered. Hence, the channel encoder provides some redundant bits to the message data in order to provide an error-free data on the receiver side. The channel encoder play an important role in the communication system. Baseband signal. In case of the low speed wireless transmission, the baseband signal can be transmitted directly. Channel. The communication channel is the media viewer, which the signal is transmitted from the transmitting end to the receiving end. It is the part of the model at which maximum noise is added to the signal. Baseband decoder. The baseband decoder is used to recover the original data from the pulse shaped or line coded data. Channel decoder. The channel decoder, after deleting the frequency, does some error corrections. During the transmission, the signal might get distorted. This is corrected by adding some redundant bits to the signal. This addition of bits helps in the complete recovery of the original signal. Source decoder. The resultant signal is once again digitalized by sampling and qualifying so that the pure digital output is obtained without the loss of information. The source decoder recreates the source output. Deformator. The deformator converts the digital data into analog signal. Output transducer. This is the last block which converts the signal into the original physical form which was at the input of the transmitter. It converts the signal input the original physical form which was at the input of the transmitter. It converts the electrical signal into the physical output, for example, loudspeaker. Output signal. This is the output which produced after the whole process. Thank you all. Thank you for watching. Have a nice day.